Thank you for joining today's session. We're going to focus on EPSS and CVSS, but specifically through the lens of OPA policy engine. So my name is Nigel Douglas. I'm a developer relations engineer at Cloudsmith, and what that means is I try to take these topics and translate them in the easiest possible way. So the company I work for, Cloudsmith, are an artifact management solution provider. Think of image registry, so like GCR, think of like Docker Hub, JFrog Artifactory, these kind of solutions that place centralized artifact management. You can send your packages up, scan them, understand what they are, the provenance associated with those, and then ultimately consume those packages. So it's a middle place where you can consume from upstreams. What OPA is it's an open source project. It was originally started off by Styra. So it's general purpose. So what I mean by that is you can use in a bunch of different environments. So originally it started off by Styra. That started off in 2016. It was accepted into the CNCF in 2018. It goes through the CNCF graduation cycle. So initially starts off in incubation. This is where it goes through rigorous trials. It goes through a technical oversight committee that have to ensure that it meets certain guidelines to where it eventually becomes graduated, as we saw in 2021. As of last week, it's now, I guess you could say it's under the family of Apple. Apple have done their best now to take on the employees that were working on the OPA project. And I guess that's just to show that the longevity of the project is being supported by Apple. So OPA, what it does is it decouples decision-making within the policy enforcement engine. It consumes the data in JSON structured data. So I'll show you an example of that in a second. And the use case you can use it for are a bunch of different conditions. You could use it for enforcement as a way of making sure that something you don't like or permit doesn't happen, but also to ensure certain audit or compliance standards are upheld within your organization. As I say, it's a general purpose engine, so that means that whether you're using it in proxies, Kubernetes, CI/CD pipelines, like we're going to talk along in this example with Cloudsmith, or you can use it in other places. You can use it, whole bunch of examples. OPA is great for that. It's also really highly performant, which is a scenario that we need to touch on in a while. Again, it works preloaded, runs in memory, and that's fantastic. So when we talk about the structured data, as I say a second ago, it's all done in JSON format. So this is great. The CVSS and EPSS data that we're going to talk about in a short while is going to be in JSON value. So we consume the data in the JSON value, JSON format, and then Rego is the associated programming language that we're going to use for OPA, and that's where we actually make these decisions on what we do and don't permit from that JSON content. So here's a perfect example. You're going to have data that's all structured JSON on the right, and you could have a list of objects, ports, protocols, IDs, whatever it is, as long as it's JSON formatted. We're going to use an example in a while of just how we can use this within policy. But this is important to give this example because we can use, semver, we can use regex, whatever it is, to look for values within this complex data set in JSON format. So the three things we're going to really focus on here, and I think it's important to have an introduction of those, is the common vulnerability and exposure. So that's the CVE severities. You hear of like low to critical, high, whatever. These you have the base scores of 0 to 10. So again, 10 being the highest, that's critical. 0 being, low, it's not important. Then you have the CVSS scoring system. So again, you have a CVE, you have the ID, and you have the severities. Then you have the CVSS score. So these are like their base score of 0 to 10. And how it differs from the exploitability or EPSS scoring is that you'll see that has a likelihood. So you'll see the not point, not whatever the number is. It's the percentage probability. Now, CVSS standard's been around for 20 odd years, and that's great. It's a way to say, here's a vulnerability, and here is the extremity of that vulnerability. EPSS tells you it's the exploitability, like how exploitable is this thing in the environment? And again, this is subject to change regularly. So we have the CVSS score, as I mentioned a while ago. It's the 75 is categorized as high, and that is a metric. The CVE identifier, in case no one's seen this before, but I think everyone's probably familiar with it, is essentially just a unique ID. It's something you say, this is the identifier for that vulnerability. Again, CVEs are assigned early, So in case you're wondering why you might have a CVE, but it doesn't necessarily have a CVSS number, Essentially, you might have the ID assigned, and then it's up to the CNAs, your numbering authorities, to actually assign the number to. There's a whole bunch of reasons why they might not assign a CVSS. There's the disputed incomplete vulnerabilities example. So you might have an organization or researchers saying, look, we don't agree on that severity number at the moment. So there's certainly an ID out there, but there's no score on it. Not all CVEs are naturally scored. There's a bunch of reasons for that. But again, it might come down to a product that they're looking at that they don't fully understand the risk associated. And these are kind of things that are driven the whole EPSS score system, where you might have an ID, no score, but you'll have an EPSS score because it's the probability of exploit right now. Again, subject to change, and we'll talk about that in a while. The CNAs, there's a whole bunch of these organizations, but these are the numbering authorities. They're the authority to provide the numbers for those CVSS scores, and they can be different. Again, they're usually provided by the NVD, so you have your National Vulnerability Database, or by, again, vendor security researchers. So Wiz are now a CNA as a security vendor out there. So there are a bunch of them. You'll see GitHub or a CNA. We'll go through the different examples in a while. So CVSS is the score thing we've been talking about forever. So it's this 20-odd years. We get an intrinsic characteristics of a vulnerability, and it tells us whether or not it's risky for us to be worried about. It also talks about the impact metrics, so confidentiality, integrity, availability, that's all listed there. And there are exploitability metrics around attack vector, complexity, privileges, these kind of things that are required to get that score generated. Problem with it is, yes, it's great that it's got context-specific adjustments that are specified within that score, so why that score was given. However, this is somewhat static, and we'll come to that in a while, and why EPSS is not a static approach. So EPSS, so yeah, the first thing here is with CVSS, it doesn't really tell us, does this matter in my environment? Because you're getting a score and it's telling you this is high, but what if let's say it's Kubernetes pod and it doesn't have access to internet, but the issue is to do with a vulnerability with internet exposed workloads. You don't know, does that necessarily impact my applications different to someone else if it's air gapped? So EPSS is another data source. For a few reasons, this is great. I mentioned a while ago, there was the example where a CVE ID is assigned, but you don't have the score. Absolutely, EPSS could give you the exploitability score without need for a CVSS, which is great for additional coverage within your organization. Please, according to the EPSS project, so from first, again, it's open source, they've also defined it as a last resort. Again, it should never be used as the sole factor when defining risk. It should be something to, for instance, in gaps where you don't have a CVSS score, or it's to show the evolving state of the vulnerability. So what we want to focus on when we're creating policies in this OPA, we want to talk about things like, well, is it reachable to the internet? What was the CVSS score? Is it in a critical system? Is this going into some kind of environment that won't talk to the internet and it's not really that important, or it's staging versus production? And again, we want to know, is it actually exploitable in the wild or exploited in the world? And that's where things like KEV come into it, the known exploits. And we'll talk about that in a while. So yeah, this project's gone through a lot of changes, EPSS. What it does is it takes 14 months data. So it's a data set, it's an ML type model, and it predicts likelihood. So again, it's subject to change. It has this look back approach. So what it does, it looks at the last 2 months of that 14-month historical data. And this is designed in a way that constantly rolling, and it's showing us, like, it's essentially saying what is the exploitability now versus the last period. Again, like, it's continuously updated, so even if your CVSS scores become somewhat static, because again, you're relying on the CNAs to update this regularly, you have something that is evolving, but it's not, like, it is something that is data driven. So again, this is part of why it's a last resort. It's not something that a security researcher is saying, I gave it this score for this reason. It is a rolling thing. And again, there was previous models, there were issues with the third model, and that's why first deployed version 4. It's trying to make it more robust, and by no means is this a standard. It is something that is evolving into something that could become something of a standard to support CVSS. So yeah, here we have it. We have our EPSS and our CVSS. So if you went into one of those CAs and you dropped in your ID, you'll see all these different colors. So you'll see, for instance, what is the base score of the vulnerability, but you'll also see the exploitability score, and it'll show up something like that, like 85.5%, or a score of not dot 0 to 0, 1, 4, 3. We'll show these examples in a while. You can see the different scores the CNA providers. So you'll see the likes of Red Hat, NIST, they'll provide those scores. But again, in these cases, they're all, this CVE, they're all 10 because it's to do with Excel utils. So we went through that a while ago, and moving forward, what we want to do is looking at, well, what's the different, where the overlap exists between the two things. And like I say, CVSS scores are 0 to 10, whereas EPSS is the probability score, so percentage-wise, 0 to 1, 1 being 100. But you have also the frequency at which they're updated. As I say, these things with CVSS require update, and not all of them do. That's the static nature of CVSS. Whereas EPSS does update daily, which is a pretty cool idea. As I say, CVSS requires those researchers to be the experts, and they drive the decisions that develop that score. Whereas EPSS is the data-driven solution. So again, it's that kind of last resort for something that we can't totally on its own rely on when it comes to CVSS scores. EPSS is quite simple. It's just a simple score, and from that we help make our decisions. Whereas EPSS is really complex. You got all these different sourcing and grouping in regards to decisions that are made. And like I say, it's been around for 20 odd years, whereas EPSS is something that's becoming an evolving standard to help us make decisions. So yeah, also again, main focus exploitation. So it tells you, is it exploitable? Whereas CVSS isn't just focused on exploitation, it's also looking at what is the severity of this thing impacting our environment? So here we go. Show of hands who's familiar with EPSS. Okay, so we have a few people. That's great. Then I won't go into too much length as what the score is, mainly for those who haven't seen it before. As I say, you see scores and they'll be like 0.9241, which is 92%. It's just the way the numbers show up. And again, they'll be presented in this order. So if you used a tool like EPSSLookupTool.com, you can just pop in a CV and then it'll tell you the EPSS score. Also, what you'll get at the bottom of that page is you'll start to show the dynamic nature of EPSS and how those scores are generated. So you can look at it by all the different conditions that make that score. So again, like I say, evolving state. So you see the attack vector. Well, this is a network-based attack in the CVE. We know that the attack complexity for this to be achieved is relatively low. So therefore, it's something I should be concerned about. Also, privilege is required. It doesn't actually require any special privileges for this to happen. If it did, that would make it harder to exploit. Again, scope, nothing's changed over time. You can look at the confidentiality impact, the integrity impact, all these different groupings to make your better decision state of that from EPSS. The goal here is that we want to take all our vulnerabilities, which generally speaking, we have a lot of noise. So we see hundreds of known vulnerabilities that are out there that are being exploited. Then we want to look at the base scores, which are the 0 to 10 that we saw in CVSS. But ultimately, we want to look at that as well against EPSS to make a better decision on what should we actually prioritize, because again, there's a lot of noise there. Ultimately, what we'll start seeing as we use different data sources and correlate them is that we get fewer, let's say 100 or less, that are actually critical EPSS exploitable, but with high CVSS scores. And these are things that we could actually better prioritize and take action on. Now, again, there's no perfect decision making here. This is just a table of understanding what the metrics are and where you could better make decisions. So you could say, look, if I have a low CVSS score or low EPSS, ultimately it's safe to use unless we're in a regulated environment that tells us we're not allowed to use it, for instance. However, if we're seeing things like where we have critical CVE number, but ultimately we're, like I mentioned a while ago, internal air gap, something on those lines where you have, it's not a big issue for us or it can't be exploited, then it's something, we could probably still run with. It depends on it. There's also other contexts we need to play in. It's things like, is there a fix available? We'll show this in OPA and why this is great, but ultimately, if I have a critical CVSS score, I have EPSS telling me it's highly exploitable, but there's a fix available. Just fix it. It makes total sense why I do that. However, not all CVEs have fixes. Some are outstanding. Kubernetes has vulnerabilities that can't be fixed. They're just outstanding, and that's understandable. So again, you start to interpret the data and then make decisions on what you want to take action on. So this is another kind of view of what you could take or impact you could apply. So you could say, look, I have a CVE 2547981. It's got a CVSS score of 10. but it's relatively low, or in fact, very low EPSS, doesn't exist in practice. It's not something that we're normally going to see. But if it's got, for instance, relatively low EPSS or relatively high EPSS, we could make decision, okay, this is something I should try to fix. And if I can't fix it, at least I should block it if it's high EPSS and high CVSS. So you can start to make more informed decisions about the things you take action on. So again, there are real examples of this where there's the high CVSS and the low EPSS. For example, this CVE at the top, the first one, it needed, for instance, a specialized path for it to be achieved. So when they actually looked at this exploitation in the wild, you say, look, this is something no one's really going to get any luck with, even though it has that critical CVE that you see of 7 or high CVE. Same with the other example. It's another one where you need to craft a specific file. It needs to be an XML file for this to work, and the chance of the person exploiting that is limited. So again, you can go into those feedlysources.com. It's just another documentation of why the scores were justified the way they were. But it's just examples of where you could say, okay, even though it looks scary based purely on the CVSS, there's actually very little chance of this being exploited. On the flip side, there's going to be examples where you're going to get high EPSS scores and no CVSS score. And those are very clear. In one of these cases, Citadel, they pointed out on that top CVE, the PHP CGI one, that, look, we knew for about 3 days about this. There was no NVD publication, and that's frustrating because if you were basing pure on CVSS, yeah, there's an ID out there, but you didn't do anything because you were based on one source data. Similarly, in the second example, it was the same thing. NVD hadn't published it yet, but there was EPSS threat intel. Again, it's kind of this perfect example of that last resort. When you didn't have the other data, which we rely on heavily, we should have another source to make decisions on. So yeah, let CVSS drive decisions alone. There's perfect examples of why that's a problem. We want to enrich it with different data sources. EPSS, the likelihood. We want to know KEV, which is the known exploits and vulnerabilities. And then also things like exposure context. Is it reachable? Is it unauthenticated? Or is there a fix available? We want to look at these kind of things so that we can actually make real decisions. So traditional inefficient workflow, security tool, you see this process you've seen times where you create a generic ticket, you say, we found something, we look into it, eventually we find out, oh, there's actually no fix available, so there's nothing we can do, we just wasted some time. Or if there was a fix available, but it turned out it wasn't something that really mattered, we just spent a load of time trying to fix something that actually wasn't a real issue within our organization. So what we're trying to do is use OPA in a way that can help us make those decisions quicker. So as I say, EPSS has its own flaws. It relies on the fact that it has to have that CVE ID. If there's no identifier, you don't see anything for the EPSS score. So it does have its own flaws. It's not a perfect system. As I said, we need to rely on other things like KEV. There's stakeholder and vulnerability sources. We talk about these all day, about all the different sources that people could apply in their organization. One of the gold standard around how you take action. So this is where you say, well, is it critical? No, move on, right? But if it is, well, is the asset exposed to the internet? If it is, let's take further action. But if it's not exposed to the internet, you can kind of skip it again. And so on the cycle goes. So is it reachable? And again, reachability analysis, that's another thing. You see vendors like Endor Labs, and they're also looking at this as another, I don't know what they call it, call graphs, I think is the term they use. So again, you can make these kind of better informed decisions when you're going through. So again, you look through a smarter vulnerability cycle, you identify the CVE, you got the CVSS score, you look at the EPSS exploitability. At this point, once you know that there's a fix available, then you can apply a ticket. And again, this is much better than the scenario where we were just filing blind tickets and wasting a lot of time for our organization. So again, when you look at that example of where we had the high CVE, but where you look where there's a fix available, do you see where it starts getting smaller? And then we look at, does it have exploit available? Then you also, if you go further beyond the scope of Cloudsmith and you say, is this going to be something that's going to be in use, for instance, in like Kubernetes, that's where that container image is going to be used, that's got that vulnerability, then you can decide, again, what are the things to focus on. But even if you went before the whole in use, not in use, in production scenario, you also just want to know, does it have fix available? Something I prioritize. And does it have an exploit that is high exploitability? That's something I want to prioritize. So again, you take down that scenario where you have like 117,000 CVEs to something more manageable that you can take action on. So let's talk about the policy scenario. So OPA, the big deterrent a lot of organizations face, they say, oh, regos, super complicated. There's no way you can make me write a REGO policy. And actually it's not. It's kind of a standard at this point. So as I say, it works in a bunch of different environments, so the same language over and over again. This is a simple example that's just based on a tag check, and this is just so you can get familiar with REGO. So in our case, we're using the Cloudsmith implementation of REGO. In this case, we specify what is a required tag, and this is the ready for production. And all we're saying is if it has the tag and we see at least one example of it, then we're good. This is something that will action, like it could be to tag something or quarantine. But again, you wouldn't necessarily quarantine it based purely on a tag simple as this. But this gives you an idea. Here's something we're matching it based on a tag. So when we're building policy, also the reason for going around OPA and that whole declarative implementation was that, okay, you have a very simple example here where you have a repository, you have your different formats, so Helm, Python, Maven, Docker, whatever it is that you're building, and you're building in a centralized artifact management platform. Then you have all the different packages within those formats. And as you scale out, as you create more repositories, you have more formats, you have different package names, this becomes a bit frustrating. So again, the OPA solution is that we can make it declarative, but scope it to these different policies and make something more standardized across a sprawling environment. So you start to get these, and I know this is where people start getting frustrated with REGO. It looks complicated, but actually it's not. So as I say, the first thing you want to do is scope it to a repository. So you say, look, staging, production, whatever that is. That's where we say, look, you can see if the count is we're going to have at least one or more than one. So we're saying, okay, if there's an example of that target repository being matched, and it's got the name within the repository name. So again, we have the schema that we define and all the data is in JSON format. So we say that's perfect because OPA handles JSON format. So we're scoping it to a specific repository. Then we're saying, well, is the vulnerability in a specific CVE number? So we can say, or ignore list. So we can say, well, we're not going to take action on those CVEs because we know they're something we've been looking at for a while now. So we want to exclude them from detection. We also want to say, for instance, is the score above a fixed number? Like I say, that's too arbitrary on its own to be just say, block everything that's over 7 because we have context. We don't know what's going on and it wouldn't be something right to just block on its own. So then you also start adding additional rich context. So you say, well, I want to do it where the score is over 7, but where it's, the vulnerability itself is over 30 days. And then we can start using this kind of RFC logic where we can start looking at publishing date and just basically say, look, it's over the value of 30. You can add custom messages. Again, it's another really powerful use case for OPA. So when you know that something got blocked, you also want to say, for instance, I got a vulnerability, but the reason the CVE score was 7.5, but the rule said it had to be anything over 7 was going to get quarantine. So again, you get better idea of why that decision was matched or made. And then the big part here is like, is a fix available? If there's no fix available, then there's nothing I can do about it, not really. So maybe I just wanted to have a tag action on those non-fix scenarios to say, look, there's high CVEs, but there's nothing you can do about it right this moment in time in regards to a clear fix. So if it is fix available, that's the one you might want to quarantine so that you can go and take action immediately on those dependencies. Again, you can do a whole lot of additional context where it starts getting a bit complicated, where you can start using regex. But again, really good use case for why you might do that is, let's say you want to scope to specific file names, or you have your own organizational design around file names or package names. So you might say, look, if the input is a package and the package name starts with package file name h11 dash, it doesn't really matter what the context is, just that's a string. And then we're saying, well, show me if it has a specific semver match, so if we're seeing, the major minor patch. So you could say, look, if I see something with that regex format, then I want to say, well, they're the other thing I want to add into the scope of my policy. So again, OPA lets us be as declarative, as fine-grained as we want to be when we're building these policies. Again, some can be very basic like this. As say, the more data we expose in a schema, the more things you can match within a policy. So if I wanted to match it on things like architecture type of a package, I could say, well, if it has the architecture is not AIM64, then I want to implement that context into the policy. Again, these things are really straightforward to write once you start testing them. What you end up getting is these examples where you Make a HTTPS post is how we'll create the policy. As I say, it's just a JSON formatted policy. I also send a post request to create an action, and the action will take quarantine. So you can say on the moment of synchronization, well, that's when the quarantine will happen. So you can see it was fully synced, quarantined instantly. So again, OPA is blazing fast, but again, the scalability piece is why this really matters across so many repositories in our environment. Yeah, this is a perfect example. I just downloaded a random pip package that had the specified architecture that we saw in that policy, so that when I tried sending it through to the repository, it quarantined it. Again, that's not related to CVSS. That's based purely on some content that came out of the package type. You can see the architectural view inside our product. This isn't a sales pitch. That was just more the idea that these are things you might also want to add into policy decision making. As I mentioned a while ago, you can use regular expressions. So regular expressions are a really powerful use case where you say things like file names that have debug, test, temp in it, followed by some form of a wildcard in the package file name. That's great. There's something I might want to scope to. So in this scenario where I download debug.py, which is some Python package on pip or on PyPy, then I can just pull that down, and when I send it up, we can see wherever it showed up in the file name where I see debug, even though it's called debug.py is the file name, that thing will take action on it. You can quarantine it. You can use semver conditions to say if a version of a package file name is before a version. There's so many versions, like this is one version before 0.16.0. Again, whatever the logic that you want to use, you can be pretty flexible with it. Again, same thing again on synchronization stage, which is when you send up the H11 with the 0.1.4, which is certainly 2 versions younger than the policy we set there, or older, then it's going to get quarantined. So yeah, you might also want to set ceilings when it comes to CVSS scores. So you might say we have a max allowed CVSS score in it, so it's more of a allow list when it comes to what you permit inside the organization. So we saw here you can set max allowed list at 9, and then the ceiling hit is basically if a score is greater than whatever was the max allowed CVSS score. You can also scope it to specific package names and versions, like we showed the wildcard scenario earlier, or you can be very explicit and just say, look, if I see flow eyes and it's using 3.0.5, then that exact match is something we could apply policy to. It depends on your organization. That's the beauty of OPA. It really allows you to make policies that are unique to you, and it's not the same policy for everyone. And then you'll have some form of, look, that's the final decision. So the ceiling was hit, and you can have a reason message that will basically say, look, it was exempt because it went outside of the scope here for that name version and allow CVSS score. So again, why this example isn't perfect is once you've quarantined something, even though that EPSS score, as we mentioned earlier, or CVSS scores are subject to change, the thing's already quarantined. So you kind of have to decide, okay, I'm going to release it so that if a policy evaluation happens later, we know if it's matching something correctly or not. Now, organizations will look at the different things, say, okay, look, I can manually scan a package. Here's an example of using Trivy just to see what the vulnerability score. We do that behind the scenes when it comes to Cloudsmith. So again, you can either do this manually here, or it's all done from here. From Cloudsmith, we automate that process. But you can see here, our AI image is the thing that I sent up to Cloudsmith. It's probably very unreadable, that blue text on black background, but basically it shows state is quarantined. So we know the thing's quarantined. You can check package state, and of course, checking the package state will show you that that thing was quarantined by a policy, and that's great, So the OPA policy worked, and that's what was the decision that makes sure that thing was quarantined. Now, this is an OPA thing, this is nothing to do with Cloudsmith specifically. You have decision logs. So decision logs give you all that kind of rich data. It's really verbose about what's going on with OPA. So in our case, when we were saying, okay, you make a policy, whether it's broad or specific, you scope and you say, okay, I've made a decision based on a CVSS score. You can go into the decision logs then, and you are making more informed decisions about what am I doing next. So you can see here, the CNAs we talked about a while ago, those CVE numbering authorities. So you have the likes of GHSA, Bitnami, Red Hat, I'm sure there's a dozen other examples. They'll say, look, we are this vector source, this is the score we gave, they're all 8.8, so it's nothing new from each one. And then below it, you have the EPSS score, which is the percentile score you see there, which is like the probability of that thing being exploited. So again, you've got the different data sources there in the decision log. You also have the advisory database, so you can always go to that link to see, okay, what was the advisory that provided that information. You can see the versions affected, and as well as that, you get the specific vulnerability details. All this kind of shows up in decision log, so you make a better decision on, okay, that's the thing that's being scoped, being matched, and also these are all the different advisory sources. So the more data we bring into it, the more things we can show up inside our decision log output. Why are we doing all this? So, let's say I create that package. I said I sent it up to Cloudsmith and it gets quarantined. So now I have a Kubernetes deployment manifest, and that deployment manifest is pointing to a container image at docker.cloudsmith.io. So that image is quarantined, so it's unusable at this moment in time. So if I try to do kubectl apply on that deployment manifest, as you can imagine, it shows error image pull, and I'm unable to use it. It's going to show 403 forbidden by Cloudsmith. So this is really important. It's like we don't want to be breaking things. Again, a lot of organizations will opt for the option to tag with the additional context based on it or view based on the decision log. But the main thing here is, blindly quarantine based purely on CVSS score might not be a great option too. We're just going to break a lot of things in production. So we want to make more better informed decisions about what things we can and can't permit in our environment. Yeah, I don't know why I added that extra slide there. Continuous scanning, it's kind of one of the approaches we've applied here at Cloudsmith, but again, organizations can apply something similar if they want, but it's just how they want to take data in. So as I mentioned, we had Trivy. Trivy's tying to all those known CNAs. So we see, look, these are CVE database that we're plugging into. The refresh rate on that, 6 hours. And as for the EPSS data, that's every 24 hours. Again, it changes every day, so we're getting it when it happens. I don't know how I never actually showed it in a policy example until now, but this is an example with the EPSS score in it. So you said, look, I set my max EPSS. I actually set it on the absolute lowest number you could. So again, this would capture anything that had an EPSS score on it, so not really useful. But where this could be interesting is those scenarios where, for instance, like you have a high CVSS or CVE, like we see here, you have the high severity on the CVE. But it has an EPSS score associated with it. So where you, for instance, you don't have a CVS score we mentioned earlier, but you do have an EPSS score, at least we can say, look, this thing is exploitable. Not currently any CVSS scores declared for that CVE. Again, what even is high risk? This is going to be every organization's going to define what risk is for them, and that's unfortunately why OPA is such a fantastic solution, is that you can scope it to match your specific requirements. So again, if the CVS score is considered high, you know that the EPS score is going to change. So you may need to review this regularly. So it's worthwhile, again, looking into those different options. Again, if a package is high exploitability score, but the CVSS isn't being adjusted, this is something that we need to look at. Look, is fix available? We look at, again, what is the context for your environment? So is this something that is going to go into production? So we need to look at the different repositories they're being used on. Or we want to know, is this reachable to the public internet? So you make those decisions yourself. Again, kind of closing remarks on this is that we have a specific vision that it's all going to be policy as code, and that's not too surprising, I'm sure, to everyone in this room. We do infrastructure as code, and it's all done by policy. It makes total sense why our security controls are also driven by policy decisions that are scoped correctly to your environment. So when we talk about this policy transparency, you want to start getting real interesting outputs to say, this vulnerability has a score that exceeded a number, or we have a score over here, but it also has an EPSS that went above the permitted threshold at a moment in time. So rather than you needing to jump to different sources to make those decisions, you really have a better informed output that you can actually take action on. So our approach, again, which is quicker, which we see CVEs disclosed, we detect it, then we have the automated quarantine. We went through all that a while ago, but you want that actionable alert. It's that thing that you can say, okay, I can actually do something about it. If you're sending a hook, but the information's not that interesting, what are you actually going to do with it? It's just going to be the same as not having information at all. So again, taking different data sources, CVSS, EPSS, exploitability. We also want to say, is it in use? Is it fix available? Yeah, again, loads of different reasons. And again, scope it differently depending on environment. What you do in your staging environment is certainly not going to be the same as production. So again, being the we try to do a few things with OPA. So, again, open source is really powerful, and that's why we're all here. So osv.dev is another fantastic data source, but this is specific to malware insights. So being able to plug into osv.dev when it comes to, the OpenSSF malicious packages project within Cloudsmith EPM, that's our policy implementation of OPA, we can make very simple policies like this. So if you've ever seen example with the packages project, the way you have CVE-2025, whatever the number is that's at the end of it. With theirs, it'll be like mal-whatever the identifier is. So if we were to create a policy, just say, well, if you see CVE ID data in the schema showing mal-something, I want to just quarantine all of it because it's all malware. And that's something you can do. So again, this is beyond the scope of CVEs and vulnerabilities, which is what our talk's about. But I guess my point is these are open standards that you can plug into. Policy is really declarative, so being able to tuck into different data sources. So even if we're talking about malware, you can still do something similar. Again, here's a perfect example from recently. There was this ES-lint vulnerability that everyone's concerned about, and it was very easy to just quarantine it because I just looked for anything that started with mal-. Going into the decision log, as I mentioned briefly, comes a decision log. This isn't a Cloudsmith thing. You can say, show me the decision log for that policy ID where I plugged in the slug perm, which is the ID associated with it. It's just an environmental variable. And then I'm JQing, so I'm just extracting all the information I want to see, like ID, summary, affected, those kind of things. You end up getting this like really great picture of like, say I mentioned a while ago, you get the ID at the top, which is like mal-year-ID. You get all the information about it. So like what version is affected, what is the name of the thing affected, and where's the source. So it's coming from OpenSSF. The OSSF project is where malicious projects is, or malicious packages I keep calling. And yeah, you have all the support and information there. So I'm just looking at where we are with time. Okay, we have 3 more minutes. Basically, look, we have a full, I hate when people use the term comprehensive, but it is comprehensive platform when it comes to artifact management. So we take different data sources from, packages from Python, Docker, NPM, Maven, we're adding Hugging Face. There's a whole bunch of examples there, over 30 different formats. But again, plug it into your different CI/CD platforms. Use the like Aqua's Trivy for scanning, but also we're trying to take in data sources from different providers. And in the sales pitch, so I'll move off. If you want to read more about this, so I published one blog on all things open, and it was just that idea of trying to come up that golden path, that golden process. Shouldn't use the term golden path, but golden process for taking action on vulnerabilities. We are creating a cookbook. I know it sounds like a silly thing to say, but essentially it's just a GitHub application where we have all these different Rego examples. And what we're trying to say is, look, if people are afraid of Rego, then let's just show you as many possible examples of scoping to something in your environment so that you can make more informed decisions. I also published a Cloudsmith blog on the vulnerability piece, the OSV, so the malicious package source data. And then again, that's in top left. So yeah, there's 3 different examples, and I'll leave it to a Q&A if there's any questions. Okay, yeah.
Do you scan your own packages?
Oh yeah, sorry, we have a microphone there, sorry. I don't know how to.
So, do you scan your own packages, for example, Trivy, because you use Trivy?
Yeah, I believe so. So there's a piece we wrote before on using Cloudsmith to secure Cloudsmith. So yeah, we also have our own Cloudsmith repository for scanning things that we use internally within our production systems.
There was like one critical vulnerability in Trivy itself. If you pass invalid Java version, it will just hang forever.
Okay.
So yeah, that was interesting.
Yeah, I'm not familiar with it, but that's good to know. All right.
Maybe I'm curious. Yeah, I'm curious on your ideas about the value of using Rego, because you could have implemented kind of any scripting language to do policy. But if you decided to go for Rego, there's probably more reasons besides, I don't know, nerds like Rego. Curious on your experience.
Yeah, it's a really good point. So like, I think we see a world where, look, more and more organizations are using Rego. So even just as a perfect example, within Kubernetes, If I was to tell a user, okay, I want them only to use upstream Cloudsmith as a source, and I want to scope this to pods, deployment, services, whatever it is to point there, I would tell them use Gatekeeper. And again, the beautiful thing is here, whether you're doing that at the Kubernetes, the abstraction, or sorry, the orchestration layer, you can easily have Rego formatted there. Again, you're using on pipeline. I guess what I'm saying is as different organizations start to use it, it becomes something of a standard that everyone's writing in Rego. And that same logic, once you've learned it, you can apply to different things. In a similar way to everything in Kubernetes, when you create something, when it's declarative, you do that in YAML. So it makes sense that when we're making decisions here, we should do that in Rego. Yep.
Can you talk a little bit about the differences between Kyverno and OPA?
Yeah, it's a good one. I actually don't know enough about Kyverno, so I'd feel like I'm doing bad publicity for them. If there's no other questions, thank you very much for staying till the end, and have a lovely rest of the day.